In this example, we want to graph three different relations that are given in A, B, and C. Each of these relations is given in roster method. And so starting with A, we would pronounce this, we would say this verbally, so we could express this relation verbally as saying the set of all points M, 3M, such that M is equal to 0, plus or minus 1, plus or minus 2. So we're given in roster method, we could express that verbally as I just did. So in order to graph this, let's think about how we could represent it as a table. And that's often useful to do before we graph something, to think about the set of points that would satisfy that relation and map that out in a table. So I'm going to set up a table in the following way. I'm going to have two columns. And the first column going to be the x coordinate of the points in this relation, and the second column is going to be the set of y coordinates. And so we can see here that M is the set of x coordinates, so we have x in this relation is equal to 0, minus 1, positive 1, minus 2, and positive 2. And for each x value, the corresponding y value we get by multiplying x by 3. So for example, when we have 0, the y coordinate would be 3 times 0, which is 0. And when we have minus 1, the corresponding y value would be 3 times minus 1, which is minus 3, and so on. Okay, and so for the last one, we would have when x is 2, the corresponding y coordinate is 3 times 2, which is 6. So this means as coordinates that we're going to plot in the plane we would have the point 0, 0 satisfies this relation, the point minus 1, minus 3 satisfies this relation, 1, 3, minus 2, minus 6, and 2, 6, and this is it. So there are a total of 5 points that satisfy this relation. And so graphing that over here, on the axes that we have, we would plot these 5 different points. So I'm going to plot them in red. So we have 0, 0, that's the origin. We have the point minus 1, minus 3. That is about here. We have the point 1, 3. That is there. We have the point minus 2, minus 6. That goes about here. And then we have the point 2, 6, which goes over here. So our graph is 5 points in the plane. And we can see that roughly these points sit on the same line. And so we'll talk about this in the next chapter, but we could express this using an equation as y is equal to 3x, where x is equal to 0, plus or minus 1, and plus or minus 2. So to summarize this example, we had the relation given in roster method. We expressed it in words. We wrote out a table for this relation, and we could graph this relation. So we can express this relation in many different ways. Okay, next let's go on and take a look at part B. In part B, we have the relation up here, which is given in roster method. And so verbally, we could pronounce this as the set of points to y. That vertical bar we pronounce as such that y is strictly less than 3. So this means that all of the points in this relation have the same x coordinate, namely 2. Okay, and we see that from the fact that the x-coordinate is 2 over here, and the y values are strictly less than 3. So again, we could set up a table to express some of the points, but we'll see here it would be impossible to list all of the points that satisfy this relation. And so if I have x, y, all of the x coordinates in this relation would have to be equal to 2. And then we can think about some values that would satisfy this relation. So for example, y equals minus 6. Well, minus 6 is less than 3, so that would be here. 2 minus 3, that's another point that would be on that line. 2, 0, 2, 2 is another point. 2, 3 over here, we need to be careful that because this is strictly less than 3, this point is excluded. And so when I start to plot these points on the graph, and now on the axes, I can start to plot these points. And so all of these points, again, have the same x-coordinate 2. So we said 2, 0 was on the graph, 2, minus 3 is on the graph, 2, minus 6, well, that would be someplace over here. 2, 2 was on the graph, but 2, 3 wasn't. So it would be tempting to, for example, draw a line like this because here we need to consider all values of y that are less than 3, so not just these integers. But if I draw this line, I've missed some points that would be on this. So for example, the point 2.9, that satisfies this relation. The point 2.99, that satisfies this relation. So we need to include points that have a y-coordinate bigger than 2, but they need to be less than 3. So the way that I do that is I put an open dot at 3, and it would be the vertical line going down, and since y is less than 3, we never hit a lower value of y, we go down forever. So here I have a line segment which has an open dot at the endpoint. So when the value x excluded, we put an open point, an open dot at that point. Okay, and for the last one, part C, we have a set which is given to us in the roster method. And in words, we would say this is all x minus 1 such that x is between minus 2 and 4. And we would say that here x is strictly bigger than minus 2 and less than or equal to 4. So we're going to include one endpoint when x is 4 and exclude the endpoint when x is minus 2. And here we could just make the following observation that in this case, all of the points that satisfy this relation are going to have the same y value. Okay, and x is going to vary from minus 2, excluding minus 2, up to and including 4. And so we don't have to, but I think it's useful to get comfortable using all of these different representations that we have, all of these tools. So writing this as a table of values, some of the points that satisfy this relation, well, all of the y values are going to be minus 1. And we start at, say, minus 2, but we need to be careful that this point is going to be excluded. But we would include any value that is just of x that is just bigger than minus 2. For example, minus 1.99, that would be a point that satisfies this relation. 0, 1, and so on, up to and including 4. So this point would be included. Since that is an inclusive inequality. And so graphing these points on our axes over here, okay, all of these points have y is equal to minus 1. So, for example, the point 0, minus 1, that was on our graph. The point 1, minus 1, that's over here. The point 4, minus 1, that's over here. Everything in between those 2 points are included. The point minus 1.99 minus 1, that's over here, right before we get to minus 2. And then this point, which is excluded, we put an open dot here. So now we include all of the points between here and here. The point which is excluded has an open dot. And the point which is included, this one has a closed dot. And since all of these points have the same y-coordinate, they all sit on a horizontal line through y is equal to minus 1.